Welcome back to Math Video Tutorials, and thank you for tuning in to this tutorial in which we will take a look at the properties of inverse functions. We're going to start with the first property, and that is the fact that the composite of the function f, or any function f, with its inverse will be still the same if we switch the order, and it will return the value itself, x. So that's the first property. Now, to illustrate this one, if we take a value x equals 17 and we do the composite of f with its inverse at 17, it will give us 17. If we switch the order, we do first the inverse composite with the function f at 17, it will also return 17. Alright, so that's property 1 of inverse function and its original function. Let's do property number 2. Property number 2 of inverse function is that the function f, the original function, and its inverse are a reflection of each other about the line y equal x. So if we could just illustrate, let's say this is my original function f of x. I'm going to take this point here, I'm going to project it here, and the inverse function will be a reflection about y equal x. This is property number 2. Let's take a look at property number 3. If I have a function, any function f of x equal y, this is my domain. These are the values of the domain. These are the return value, the output are the range. Now, if I take this value y and I plug it into the inverse function, it will return the value x. So this is now the domain of the inverse function, and this is the range. Property number 3 is that the domain of the inverse function is the range of the original function. The range of the inverse function is equal to the domain of the original function. So that's property number 3. Property number 4. We know that a function can be one of these two types, either a one-to-one type of mapping or many-to-one. So let's do some diagrams. One-to-one looks something like this. This is the function f. We have one value from the domain, links up to one value only from the range. Do another example, and so on and so forth. 1 to 1. Now, if I did the inverse of f, then I would go the opposite direction, start from the range, and go back to the domain. So this will be my domain. This is my range. Same thing here. Same thing here. So you can see the function f is a one-to-one. It is a function, and the inverse is also a one-to-one. Is a one-to-one function. So a one-to-one will produce an inverse function which is also one-to-one. Let's have a look at the many-to-one now. Diagram. So we have many to 1. This is the function f, and let's do another example. Many to 1. Many from the domain to one from the range. If I do the inverse is going to be from the range, goes that way. That way you can see the inverse will produce 1 to many. Same here, 1 to many. So this is the range, this is the domain. So for this one here, a many one-to-one function will produce a 1 to many. So this function here, the inverse function, is 1 to many. So that is not a function. So you can see we got a problem here. A many to one function does not produce a function. So we can conclude that for the property number 4, for a inverse function to exist, the original function f has to be a 1 to 1. And just to recap the tutorial, I wrote down the conclusion that an inverse function to exist, the original function has to be a one-to-one type of mapping, and that's what we try to explain here. Alright, I hope this video tutorial was helpful, and thank you for watching.